Hi everyone. Hope you have enjoyed my first session on the types of solids, that is the crystalline and amorphous solids. If you haven't, you can please find the link in the description box below and watch it before you continue with this video. In today's session, we shall move further and study more about the different types of solids. Now, broadly, the solids can be classified into four categories. You can have ionic solids, which are made up of ions. Then we have the covalent solids, which are made up of covalent bonded molecules or atoms. Metallic solids made up of comprising of the metal atoms, and the molecular solids, which are comprising of the molecules. Now, these molecules are further categorized into three types. That is, you can have the polar molecular solids, the non-polar molecular solids, and the hydrogen bonded molecular solids. So in today's session, let us understand a bit about all these types of solids. We begin with the ionic solids. Now, as the word ionic suggests, these are comprised of positive and negatively charged ions. And the most common example for the ionic solid is sodium chloride. As you're aware, sodium donates an electron to form the Na plus ion with a net charge of +1, while chloride ion has a negative charge of unit magnitude. So this positively charged Na plus ion and the negatively charged chloride ion are bound together by electrostatic forces of attraction to form the ionic solid. So let us see the characteristics of this ionic solid. So as you just saw, the constituent particles are ions which are held together by the electrostatic forces of attraction. Now these solids are generally very hard, but at the same time they are brittle, that is they can break easily. Due to the strong electrostatic forces of attraction, these solids have a very high melting point. However, in the solid state, they are non-conductors of electricity. But when prepared an aqueous solution, then these solids can conduct electricity in the aqueous form. Or even in the fused state, it is seen that ionic solids can conduct electricity. Because when the aqueous solution or the fused state is formed, then the ions are they get dissociated or the ions are free to move around, and that is why the solution of ionic solids in water, that is an aqueous medium, or the fused state of the ionic solids are capable of conducting electricity. So here are a few examples of ionic solids like sodium chloride, potassium sulfate, calcium fluoride, etc. Now moving on to covalent solids. Now as the word suggests, covalent solids means they are bound together by the covalent bonds. So the most common example of covalent solid is graphite and diamond. Students, I'm sure you remember that carbon has the property of catenation. And as a result, many carbon atoms can join together to form huge molecules or huge solids rather. So in the covalent solids, the constituent particles are basically atoms and usually that of carbon. These atoms of carbon are linked together by covalent bonds, and the bonds are so strong that the solids are generally hard and incompressible. In fact, diamond, which is an example of covalent solid, is one of the hardest substances known. These substances have high melting and boiling point due to the presence of the strong covalent bonds, and they are poor conductors of heat and electricity. Exception, graphite, which is a good conductor of electricity, but generally covalent solids are not good conductors of heat and electricity. They are poor conductors of heat and electricity. Now moving on to the next type of solid, that is the metallic solids. Now as the name suggests, metallic solids, they comprise of metals. Okay, so here you can see a copper wire. I've tried to show you the enlarged view of the atomic state of this wire. So here you can see in this metallic crystals, the metal atoms are present in a sea of electrons. The positively charged metal atoms, they are bounded together or they are embedded in a sea of electrons, we can say. The valence electrons get released or they are in the movable state, as a result of which the metal atoms are embedded in a sea of electrons. So here the constituent particles are metal atoms, and the bonds that are formed here, which holds the metal atoms together, are called as the metallic bonds. That arises due to an interaction between the metal cations and the mobile electrons, or the electrons which are free to move. These metals are generally malleable and ductile. Okay, so malleability is the property wherein you can beat the metal into thin sheets, and that is the reason why we are able to make sheets of tin or sheets of aluminium which are used in the bodies of the vehicles. And ductility, or metals are ductile. Ductility is a property by which the metals can be drawn into very thin wires. Okay, and that is the reason why you have gold and silver being used in ornaments. You have copper wires which conduct electricity, very thin wires you can generate. So that is because of the property of ductility. Then, most important, the metallic solids are good conductors of electricity as well as heat. They are good electrical and thermal conductivity. Okay, so they find a lot of applications in the electrical industries. Another important characteristic of metals which other solids do not possess is that of luster. Due to the mobile electrons which are present, okay, there is absorption and emission of light energy, energy which falls in the visible region, as a result of which, when the metals get excited, the electrons get excited, they move from one level to the higher energy level and emit radiations which are visible, so emitting the luster or the shine, so which is a very much characteristic of the metallic solid. Moving on to the last type of solids, that is the molecular solids. Molecular solids, as the name suggests, comprise of molecules. So we have here examples of silicon dioxide, that is silica, and silicon carbide. So these are molecular solids. Even you can have examples of hydrogen sulfide or sulfur dioxide or carbon dioxide. These are all molecular solids. But only thing is, some molecular solids, or rather most of them, exist in gaseous state at room temperature. However, upon cooling, they do get converted into the liquid state, and finally they can be compressed into the solid state. So you're very much aware of carbon dioxide, which exists as a gas in nature, but then on compression or on cooling, you can convert it into solid carbon dioxide, which is commonly known as dry ice. So here in molecular solids, the constituent particles are molecules. Now these molecules are held together by different kinds of interactive forces. So for example, there can be the weak dipole-dipole interactions in case it is a polar molecular solid. The interaction is of the dipole-dipole type. If it is a non-polar molecular solid, then you will have weak dispersion forces, or what is known as London forces, that holds the molecules together. Okay, like in the case of in the case of hydrogen bonded molecules, you can have the hydrogen bonding itself helps in holding the particles together. Okay, the hydrogen bonding that exists between the molecules, where one atom is hydrogen, like for example ammonia, water, okay, or hydrogen fluoride. Here the hydrogen atom of one molecule is interacting with the electronegative atom of the other molecule, resulting in hydrogen bonds, and the hydrogen bonds are very strong. So out of all the three molecular solids, that is non-polar, polar, and hydrogen bonded, the hydrogen bonded molecular solids are having really strong intermolecular forces of attraction. Now, generally, these molecules have low melting points. These solids have low melting points, but of the three, the hydrogen bonded molecular solids have a comparatively higher melting point. Okay, they are very poor electrical conductors, and also they do not conduct heat, and hence they serve as good insulators. So this brings us to a recap of all the four types of crystalline solids. Let us have a quick recap here. So if you look at the four types, that is ionic, covalent, molecular, and metallic solids, the particles of the unit cell in ionic solid, the particles are cations and anions, okay, which are held together by electrostatic forces of attraction, which is the interparticular force. In case of covalent, there are covalently bonded atoms which are held together by covalent bonds, like in diamond and graphite, due to the property of catenation of carbon. In molecular solids, it is comprised of monoatomic or polyatomic molecules, okay, but atoms will be of the same type usually, and these molecules are held together by London forces or dispersion forces. In case of non-polar solids, in case of polar solids, you will find dipole-dipole forces of interaction, and in case of hydrogen bonded molecular solids, you will find hydrogen bonding, which holds the particles together. In metallic solids, the metal ions, which are embedded in a sea of electrons, form the particles of the unit cells over here. And the metallic bonds, hold them together. The metallic bonds are nothing but the attraction between the cations of the metal and the mobile valence electrons. Now coming to the hardness, ionic solids are hard and brittle. Covalent solids are very hard due to the covalent bond strength. The molecular solids, on the contrary, are soft and can be easily cut. Metallic solids, it varies. Some metals like sodium are very soft, but then you do have metals which are very hard as well. Now, melting point, the ionic solids have high melting point in the range of 600 to 3000 degrees Celsius, but higher than that is that of the covalent bonds, the covalent molecules, which have a melting point from 1200 to 4000 degrees Celsius. In case of molecular solids, the melting points are lower, and metallic solids, there's a wide range from minus 39 to 3400 degrees Celsius. Now, coming to the thermal and electrical conductivity, we already saw that the ionic solids are poor conductors in solid state, but generally they do conduct when dissolved in water or in the fused state. Whereas covalent solids are very poor conductors of electricity, exceptions graphite and diamond. And molecular solids again are poor conductors of heat and electricity, but metallic solids are very good conductors of heat and electricity. So this brings us to the end of our today's session. I hope you have had a quick recap of all the four types of the crystalline solids. So in my next session, I'll be beginning with the crux of the solids, that is the unit cell, and the various types of the Bravais lattices, as well as how the packing is going to be done. So I hope you keep looking forward to my upcoming sessions. Until then, thank you.